Section 3.7, example 2 on page 220, we have the graph of y equals the absolute value of x plus k. Notice this plus k is on the outside of the absolute value bars at the end of the equation. Is a translation of y equals the absolute value of x. Let k be a positive number. Then y equals the absolute value of x plus k translates the graph of y equals absolute value of x up k units, while y equals the absolute value of x minus k translates the graph of y equals the absolute value of x down k units. So in example 2, it says, what is the graph of y equals the absolute value of x plus 2? So on the previous slide, if we have a plus on the outside of the absolute values, it tells us we shift up. So I went ahead and already added the absolute value of x to the graph as a starting point. All we have to do is take these points that are here and shift all of them up 2. Once you've shifted all the points up 2, you just draw your branches straight through all the points. And just to emphasize what we're doing, the vertex here is at 0, 0. If we want to shift that up 2, we just go 2 up on the y-axis to get 0, 2. Over here, here's another point we can check, 4, 4. If we want to shift that up 2, we still start over 4, but up 6. Negative 2, 2 will get shifted up, so still negative 2 for going left, and then 4 up instead of 2 up. The next slide has a no-need plan chart to help you figure out how to graph that. And then we have all of the work with some explanations written out on this next slide. You're welcome to go look this up on Google Classroom. And now I would like you to try number 3. So graph each function by translating y equals the absolute value of x. So we're trying to graph y equals the absolute value of x plus 3. I recommend putting y equals absolute value of x on your graph and then drawing it plus 3.